Good morning, guys. This time we're going to talk about convex mirrors. For this example, we have a pencil that is placed in front of a convex spherical mirror with a focal length of 8 centimeters. An erect image of 2.5 centimeters tall is formed 4.44 centimeters behind the mirror. Find the position of the object, magnification of the image, and height of the pencil. So first of all, we're talking about an object that is a pencil. Now, what do we know about this object? First of all, we need to find its position, okay? So, for pencil, I need to know my position. I don't know it. Now, do I know about the image? The image, I know that it has a size or height of the image equals 2.5 centimeters. Now, that image is formed 4.44 centimeters behind the mirror. So that means that my image distance is 4.44 centimeters. But as it says behind the mirror, we're going to consider this to be negative. Now it says that is about the pencil, the image. Now what do we know about the mirror? About the mirror, we know its focal length is 8 centimeters. Now, this focal length is behind the mirror, because for convex mirrors we have this type of mirror, okay? So the object, for example, is placed here, and my convex mirror is this one. So my focal length, it's gonna be here internally to the mirror. So as it is behind the mirror, we consider this side to be behind, and as it is behind, it's going to be negative. So my focal length for this mirror will be negative 8 centimeters because it is behind the mirror. Now, what do we know? We know all this, okay? So first of all, we need to focus on what is given and what is requested. We need to find P. And the equation that allows us to find P is mirror equation. 1 over P plus 1 over Q equals 1 over focal length. So isolating for P will be, okay, solution 1 over P is going to be equal to 1 over the focal length minus 1 over the image distance. This is the equation that we'll be using. As you can see, it's the same that we used to use when we were working with concave mirrors. But this time, we're talking about a convex mirror, but as we're talking about mirrors, we can use the same equation. So, let's isolate. Well, let's solve. 1 over negative 8 minus 1 over negative 4.44. Let's see what happens here. One here, negative and negative is gonna be positive. So this is gonna be negative 1 over 8 plus 1 over 4.44. So it says 1 over P equals 0.100. To know P, I will get the reciprocal. So P, therefore, P is going to be equal to the same answer, reciprocal. So it, as you can see, it's 9.98. We were using centimeters, so it's going to be centimeters. Okay, you have found your P. Now, We need to find magnification. Well, magnification goes here in the image. And the height of the pencil, we're talking about h. We need to know what h is. So, to find magnification, we have the equation right here that relates the size of the object and the image. We don't have the size of the object, so we're not going to use this one. But we can use image over object negative. My image position is negative 4.44 centimeters divided by p, that is 9.98 centimeters. Cancel centimeters. So you will have negative and negative will make positive. It's 4.44 divided by 9.98. This gives us a magnification of 0.44. What does this mean? As this number is less than 1, that means that the object image is reduced. That's what it means. And so let's say you had an object of 10 centimeters, and after light hits on the mirror, then the image that will be reflected is going to be tinier than the original object. That's what it really means. So we already find magnification. Now I want to know the height of the pencil. So this was my first step. This is my second step. Now for my third step, I want to know the height of the pencil, and the only thing that relates height of the pencil is, as you can see, magnification. So you have magnification equals h prime, that is the image, divided by h, that is the height of the pencil, in this case the height of the object. Isolate for height and you will have h prime divided by magnification. H prime, that is negative 4.44. Sorry, I got confused. 2.5 centimeters divided by magnification, that is 0.44. Cancel here, and you will have, let's see, 2.5 divided by 0.44. Okay, the height of the pencil initially was 5.68 centimeters. Okay, here's the thing. I got confused here. I will erase it. Wait. Okay, here's the deal. I already erased, and as you can see, magnification doesn't have any unit. So centimeters divided by nothing is gonna give you centimeters. So what can we say? That initially my object had that size. Okay, let's imagine this is my pencil, and after it's been projected on a mirror, the image, the projection, is going to be a lot tinier. How tinier? 2.5 centimeters. So it's going to be something like this. The object, original object, and the image that is going to be reflected in the mirror. And that's how it works. Okay, so basically you have to use the mirror equation and magnification as you have been using it, but this time you have to consider the position of the object against the mirror. And remember, if it tells you that it's behind the mirror, the symbol should be negative. Now let's do one more example. Okay, we have another problem right here. It says the radius of curvature of a convex mirror is 12 centimeters. Where is the focal point located? Find the position of the image for an object placed at the following distances from the mirror: 1, 2, 3, 6, 12, 13 and 50 centimeters. Okay, so this exercise is a little bit different because they are just giving me radius of curvature, that is 12 centimeters. And they are telling you, for the first part of the problem, because as you can see it has two parts. It has two parts, one here and the other right there. So for the first part, it's asking you to find the focal point. Unknown. Now, what's gonna happen? Take a look. Remember that I showed you the other day in the presentation. It says that the radius of curvature is equal twice the focal length. So isolate for the focal length, it's going to be equal to the radius of curvature divided by 2. So this is going to be equal to 12 centimeters divided by 2. So the focal length is 6 centimeters. Now, how is this? Behind or in front of the mirror? As I already mentioned, as we're talking about convex mirror, the focal point is behind. As it is behind, this focal point basically turns to be negative 6 centimeters. Remember that when we are talking about convex mirror, the focal length is located behind the mirror. Now, what's happening in the other part? It says find the position of the image for an object placed at the following distances from the mirror. So we have in part 1, P equals 1 centimeter. I need to find Q, and I know that I have a focal length of negative 6 centimeters. In part B, I have my P equals 2 centimeters, unknown, and my focal length is the same because we're talking about the same mirror. Okay, I'll stop the video, so I don't want it to be that long. Okay, now take a look. I'm gonna do only the first 4 and you will finish as a homework 12, 30 and 50 centimeters. Now, to calculate my focal length, I will use, of course, my mirror equation. So I have 1 over F equals 1 over P plus 1 over Q. Isolate for Q, it's going to be equal to 1 over F minus 1 over P. This is going to be equal to 1 over negative 6 minus 1 over 1. So here 1 over Q is giving me negative 1 over 6 minus 1. Negative 1.17. Now we need to get the reciprocal in both sides, so this is going to be equal, Q is going to be equal to negative 0.86 centimeters. Okay. In the second part, I will use the equation isolated. Minus 1 over P equals 1 over negative 6 minus 1 over 2. Q is going to be equal to negative 1/6 minus 1/2 reciprocal negative 1.5 centimeters. Now remember that I'm getting the reciprocal, because here you have just 1 over q and here you have q, you have to get the reciprocal. Now here is 1 over q equals 1 over negative 6 minus 1 over 3, 1 over q, it's equal to negative 1/6 minus 1/3, negative 1/2. So the reciprocal of this is going to give you q equals negative 2 centimeters. Just change the position of the fraction. For example, the reciprocal of 1/2, for example, is 2 over 1 to the first power. And the reciprocal of 3/5, for example, is going to be 5 over 3. But we're not using this anymore. Okay, now let's do the last one. So 1 over q equals 1 over f minus 1 over 6. This is negative 1 over 6 minus 1 over 6. Let's see. I have negative 1/6 minus 1/6. I have 1 over q equals negative 1/3. Now to find q, we need the reciprocal of both. So q is going to be equal to 3 centimeters. Well, guys, now it's your turn to practice. Do okay, I didn't tell D, so you will do E, F, and G as a homework. I hope you have understood. And tomorrow we're gonna continue with this topic, but for ray diagrams. Goodbye.